Hi there, welcome to this video walkthrough for the NCEA Level 2 Calculus exam. In this video, I'll be going through NCEA exam style questions. These questions are based on those in the 2020 exam. Let's get started. So for question 1, a function is given by f of x equals negative 2x cubed plus 4x squared minus x plus 8. Find the gradient of the graph at the point where x equals 4. So the key thing for the calculus exam is the two main skills, which are differentiation and integration. So every question is going to require one of those skills, and most of the questions actually require differentiation. So first thing to do is to identify which of these two skills you need to use. Now the question is asking us to find the gradient of a graph. Finding gradients is always differentiation. So I am going to differentiate f of x, which will give me f dash of x. So remember to differentiate, multiply by the power, and then subtract 1 from the power, and do that for each term. And there we go, that's f dash of x, or known as the gradient function. So it's called the gradient function because it tells you how to work out the gradient of f of x, which is exactly what we need to do. Now we've been told where this gradient is, it's at x equals 4. So I'm going to substitute x equals 4 into f dash of x, and that will give me the answer. So we'll go f dash of 4. So every time I see an x, I'm going to put a 4 instead. Brackets are your friend whenever you are substituting. So I'm going to put that into my calculator and see what the answer is. And the answer is negative 65. So that is the gradient of f of x when x equals 4. So to break down what we did there, differentiated to find the gradient function, then substituted the x coordinate that we're given into f dash of x, and that calculates the gradient. Okay, on to question B. Find the x coordinate of the point on the graph of the function g of x equals 4x squared minus 7x plus 2, where the gradient is 3. So this one's actually a very similar question to question A. And they're both achieved questions because only really one or two steps are required. So it's a very similar question because it involves a gradient. Now, this question is just the other way around. So whereas the first question asked us to calculate what the gradient is at a specified x value, this time we've been told what the gradient is, but we want to know where that is, i.e. at what x value does that gradient happen. So again, anything to do with gradients and we need to find gradients or something related to a gradient is differentiation. So again, I am going to differentiate this. So g dash of x equals 8x minus 7. Okay, so we've been told the gradient is 3. So in other words, g dash of x equals 3. Because remember, this is the gradient function. So this thing here, g dash of x, is the gradient. So I know what that is. It's 3. So I can substitute that into the equation. Now that means we only have one unknown, which means that I can solve for x. So you could do this using the solving function on a graphics calculator, but it's not too tricky to do by hand, so I'm going to do that. So this is a linear equation. There's no x squareds or x cubes, so that means I'm going to solve it by rearranging to get x by itself. So first of all, I will move the separate term, the one being added or subtracted, always do the opposite. So that's minus 7, so I'm going to plus 7 to both sides. So 10 equals 8x. Then split the 8 away from the x with division. So I'm going to divide by 8. 10 divided by 8 is 1.25. You could leave this as a fraction as well. Would be absolutely fine. So x equals 1.25. So that is the x coordinate of the point on the graph where the gradient is 3. Some questions may ask you to find the y coordinate as well. If you wanted to do that, you would substitute this back into g of x and work out the gx or y coordinate. But for this one, it does specify specifically just find the x coordinate. So we're going to do that. So again, both of these first two questions are achieved questions. So typically in the calculus exam, there will be 2 achieved questions in each of question 1, 2, and 3. So if you get both of those, that will typically be an A3 for that question. Okay, so we're on to the first of 2 merit questions. So there will also typically be 2 merit questions in each of question 1, 2, and 3. And this is the first of those for question 1. Find the equation of the tangent to the curve of y equals x cubed plus 3x minus 7 at the point -2 and -21. Okay, so find the equation of the tangent. So just a quick reminder that a tangent is a straight line that just touches a curve at the point where they touch. So we've got a cubic equation here, y equals x cubed plus 3x minus 7. So that will look something very roughly like that. So at the point -2, now we don't know exactly where -2 is on the graph, but so it could be here, it could be anywhere, but this is what a tangent will look like. It'll just touch at that point. Now it's not actually necessarily there, we'll see when we get further along, but the key thing here is this point of intersection. At that point where the tangent touches f of x, the gradients are the same. And that is the first step in finding the equation of the tangent. A key thing here, we know the x and y coordinates where they touch. So that is actually at -2, -21. So at those coordinates, they're going to touch and their gradients will be the same. So use that word again, gradients. All 3 questions so far have involved gradients. Very gradient heavy, the calculus exam. And again, anything to do, if we want to find a gradient, you need to differentiate. Always differentiating if you want to find a gradient. So I will differentiate that. I could go dy over dx here, or I could go y dash, doesn't matter. So 3x squared plus 3. So I've differentiated the equation of the curve. So we know the x coordinate. Y coordinate is not relevant for this. We don't have a y in this equation, so I've got nowhere to put it. But I've got somewhere to put an x coordinate. So I'll substitute that in. So again, brackets are always best when you're substituting. I'll just work out what that is. Okay, that's 15. So the gradient of the tangent and of the curve at that point is 15. So, okay, my diagram's not too bad then. That has got a positive gradient. So we've got a gradient of 15. Great. So again, that's the gradient of the tangent and of f of x at that point only. But we need to find the equation of the tangent. So if it asked us to just find the gradient of the tangent, we'd be done. And then it'd only be an achieved question, not a merit. So to find the equation of the tangent, we need to know the x and y coordinates, and we also need to know the gradient. Now we know all of those things. We were given x and y coordinates, and we have just worked out the gradient. So we can now use the straight line formula. Y minus y1 equals m, and then brackets x minus x1. You might recognize that from coordinate geometry if you did that internal. So that's the straight line formula. M, hopefully you know, is the gradient. So that's going to be 15. And x1 and y1 are your coordinates. X and y are x and y. Because I remember our equation has to have an x and a y in it. So they're just going to stay as x and y. But what I'll do now is substitute the things that we know into that equation. So y is just y. We know that y1 is negative 21. Now we've got double negatives here, which happens sometimes. So always be careful of those. We will go brackets again. Whenever you're substituting stuff, always best to use brackets. Always best to be safe. Gradient is 15. X is x. X1 is negative 2. So double negative again. Again, be careful of that. Best practice, use brackets. All right, so we've substituted what we know into the straight line formula. Now we're going to just deal with those brackets, the double negatives. So again, just do one step at a time is always best. Don't try and rush. When you rush, that's when mistakes get made. Okay, double negatives mean a positive. So there we go. Again, just doing one thing at a time. So now I will expand the right-hand side. So remember, we want this to be in the form y equals mx plus c, because this is a straight line. So I'm going to rearrange it until it looks like that. So I've expanded those brackets. Now just one more step, which is to take away the 21 from both sides to get y by itself, and then be y equals m x plus c. And there we go, y equals 15x plus 9. That is the equation of the tangent. So again, that is a merit question. You would get achieved for calculating the gradient. So if you got to here, that would be achieved. Getting all the way to here is a merit. Okay, on to the next one. The gradient function of a curve is f dash of x equals px plus 5, where p is a constant. So p is a number, we just don't know what number it is. The curve passes through -2, -3, and 3, 32. So we've been told two places where f of x passes through. Calculate the equation of the curve. So this one's different to the other ones. We've been given f dash of x. We have been told the gradient function. Now, usually if you're told the gradient function, that's a good indication that you need to integrate. And that is the case in this one, because we've been asked to calculate the equation of the curve. In other words, find f of x. Well, if we want to find f of x from f dash of x, that's the opposite of what we did in the previous questions. So we did the opposite in all the three questions before, we differentiated. So opposite of differentiation is integration. So let's start by integrating. So we're going to do the opposite process. So add 1 to the power and then divide by the new power. And don't forget, when you're integrating, the plus c. Okay, so we now need to think about how we're going to find f of x. Now the problem is we've got two unknowns in this equation. Well, 3 actually, if you count the x as well, or 4 if you count the f of x. So we've got p and we've got c. Now usually what you would do is you would substitute some known points in to work out c. Now we're still going to do that, but that's not going to help us with the p. But we'll get there. Again, this would just be an achieve question if that was all we had to do. Now we know these 2 points, so remember it's x, f of x, or x, y. So let's substitute in what we know. So we'll do -2, -3 first, and you will see what I mean about too many unknowns. So let's substitute these values into our equation. So again, every time I see x, just put -2 instead, and again, always use brackets. Okay, so you can probably tell we've got a bit of a problem, and that problem is that we've got too many unknowns because we still don't know p and c. So on this first term, -2 squared is 4, and then divided by 2, I'll just probably go straight for 2, p, plus 5 times -2 is -10, also plus -10 would just be take away 10, plus c. Get those numbers together, so I'll add 10 to both sides, and that'll be 7. Right. So again, that doesn't initially look amazingly helpful because we can't actually work out p or c just yet. But you notice we were given 2 pairs of coordinates. So let's try doing the same thing. I'll do this in a different color with the other coordinates that we were given, the 3 and the 32. So I'll do that in purple over here. So 32 equals p times 3 squared over 2 plus 5 times 3 plus c. So again, substitute those x and y values in. So we'll just go through a bit of a process to simplify this down. So 3 squared is 9, so that would be 9p over 2, or 9 over 2p, however you prefer to write it. 5 times 3 is 15, and then c. I can take away 15 from both sides, so that'll be 17 equals 9 over 2p. I'll write it the other way just to show you it's the same thing, plus c. Okay, we've got to a similar kind of place with both of these where we simplified it down, we've got p's and c's in both. So what we need to do now is solve these simultaneously, and then we'll be able to get an answer for these. So you could do this on your calculator. I'll show you how to do it by hand as well. We'll do it on the calculator first, just so we know we get the right answer. So what we know is that those p's and c's have to be the same thing because it's the p here and the c from the constant of integration. So they have to be the same thing. So this p has to be the same as that p, and that c has to be the same as that one. So what we can do is rearrange these to give us an answer, and then we can substitute. But we'll do it on the calculator first. So obviously you require a graphics calculator for this, whether it's the 9870 or the 9750 Casio calculator. They have this solving function on you. So you're going to go menu and then equation, and then select F1 for simultaneous, and we've got 2 unknowns. So you'll see at the top of the calculator, it's a n x plus b n y equals c. So it needs to be in the form something x plus something y equals c. So we're just going to put in the coefficients of each term, so just the numbers. They are written backwards on here to how we put them in the calculator, so just be aware of that. So it's ax plus by equals c. So if we say p is our x and c is our y, as long as it's consistent for both, then it's fine. So we'll go 2, look at the first one, so 2p plus 1c equals 7. So I'm going to go 2, then 1, then 7. And for the other one, 9 over 2. If you know that's 4.5, cool, I'm going to enter 4.5. It is 9 over 2. You can enter 9 over 2, and that's absolutely fine. So 9 over 2, so A is 4.5, B is going to be 1, because that's 1c, and C is 17. Okay, so my calculator has told me that the answers are x or p is 4 and y, c is -1. Now let's double check that. We'll see how we get that by hand. I have not left myself enough space, so let's move this out of the way. That's a future problem. Okay, so if we want to solve these equations simultaneously, I'm going to do this using substitution, which means I need to rewrite them, or rewrite one of them at least. And doesn't matter if you do this for P or for C, but C will be easier for either of them because it's by itself. Both C's don't have a number that's being multiplied by it, which makes rearranging for C a bit easier. So I'll just rearrange the blue one, so 7 equals 2p plus c. Again, doesn't matter, I could have done the other one, and I could have rearranged it for p. I'm just trying to keep things as simple for myself as I can. So my objective is to get c by itself, so I'll do that by subtracting 2p from both sides. So 7 take away 2p equals c. So what this equation tells me is that c is the same thing as 7 take away 2p. And again, this c will be the same as that c. So this c over here must also be 7 take away 2p. So what I'm going to do is I'm going to substitute this one into that one. So when I see c in the purple equation, I'm going to put 7 take away 2p instead, because what that blue equation tells me is that they are the same thing. So I'm not changing the equation in that sense. It will still give me the same answer because they are the same. Okay, so we'll go 17 equals 9 over 2p plus c. So again, c is 7 take away 2p. And as always, using brackets to substitute. Now in this case, the brackets aren't actually necessary, but it's always good to be safe. So let's just get rid of those. And we'll have it all in purple now. No double negatives or multiplication or anything to worry about. So what we have achieved here is there's no c in there anymore. We've substituted it out. So there's only p's. So there's only one letter or one unknown. And if there's only one unknown in your equation, you can solve that equation to find that unknown. So this is linear again, so I'm just going to go through the same process as what we did in that previous question to solve a linear equation and solve for p, which is rearrange until the p is by itself. So first thing I'm going to do is get those p terms together. Again, it doesn't actually matter the order we do these first two steps in. So go, if you're not sure, just do it on your calculator. So we've got 9 over 2, which again is 4.5, and we'll just take away 2 from that. So that's 5 over 2, or if you press the S to D or F to D button on your calculator, it will tell you it as a decimal. So that's 2.5, or 5 over 2, however you prefer it. We'll go 5 over 2p plus 7. Then we will take away 7 from both sides. So again, just going through the process of getting p by itself. Really underestimated how much space this question would take up. So we've got 10 equals 5 over 2p, so now I want to divide by 5 over 2 to get p by itself. So again, if in doubt, do it on the calculator. 10 divided by 5 over 2 is 4. Makes sense, 10 divided by 2.5 is 4. So p equals 4. Okay, right, we found p, now we can find c. So there's a few ways we can do this, but the easiest would be to use that blue equation that I rearranged earlier, this one here. Because this one, I've already rearranged it to tell me what c is. So if P equals 4, C will equal 7 take away 2 times 4. 2 times 4 is 8, so 7 take away 8 is -1. And again, if you need to, just do that on the calculator. Okay, so we've got P and we've got C. That should be everything we need. Because remember, our objective was to calculate the equation of the curve, i.e. find f of x. So our problem was, if we look back all the way up here, after we integrated, we didn't know P or C, but now we do. So we have got everything we need to answer that question and say what f of x is. So therefore, f of x equals, I have already forgotten what it is, so it's px squared over 2. So p is 4, so it's 4x squared over 2 plus 5x plus c. So the 5x, nothing happens there, plus 5x plus c, so -1. Well, that 4x squared over 2, we can simplify that. Always want to simplify if we can. 4 over 2 is 2, so 2x squared plus 5x minus 1. Okay, on to question E. So this is the last one for this first part of the exam. Just a reminder that that previous question was a merit question. You would get achieved for integrating correctly. So all the way back here, quite a difference between achieved and merit. That happens sometimes. Okay, so on to E. So this is the one and only excellence question for question 1 of the 2020 exam. So just a reminder, these are similar questions, just not exactly the same. But in terms of the grades, they will be the same. So we have got a train passing a crossing at 26 meters per second. The train's acceleration can be modelled by the equation AT equals 10 minus 0.5 t. How far from the crossing will the train be after 20 seconds? So this is a kinematics question. People have got to talk about speed, acceleration, distance. We're talking about those things. So we've been told the acceleration. So what I always like to do is to write myself this at the side, dVA, distance, speed, velocity, and acceleration. So we differentiate downwards and integrate upwards. So we've been given acceleration, so we're at the bottom here, so this is going to require integration. Well, how far? We're asked to find distance. Okay, we definitely need to integrate. We actually, specifically, have to integrate twice, because if you integrate acceleration, you get velocity, speed. If you integrate speed, you get distance. So we're going to have to integrate twice. So let's integrate. If we integrate acceleration, we get velocity. So remember to integrate, add 1 to the power, and divide by your new power. So I think we can just go 0.25 t squared. And of course, I nearly forgot, don't forget the plus c. Okay, so we were told that a train passes the crossing at 26 meters per second. So we're going to take that as time is 0. So that's when time starts. Because everything's measured from the crossing. So at the point the train goes past that crossing, that is time equals 0. So the train passes the crossing at t equals 0. So at t equals 0, speed is 26. Why does that matter? Well, because that is going to allow us to find c. So substitute those things into the equation. That's going to be 0, that's going to be 0. We're going to get 26 equals C. So therefore VT equals 10t minus 0.25 t squared plus 26. So we've got an equation for speed, but we have been asked for the distance. How far from the crossing will the train be after 20 seconds? So we need an equation for distance. Now, if we've got velocity and we want distance, we're going to have to integrate again. Do this in a different color. Okay, so we're going to integrate the velocity equation, and that will give us distance. So again, add 1 to the power and divide by your new power. And don't forget the plus C. Can simplify this a little bit. Simplify that to 5t squared. What can we do with 0.25 divided by 3? That doesn't make a nice decimal, so I'm actually just going to leave that as it is. I will just write it like this. Doesn't matter, it's the same thing. Plus 26t plus C. So again, we don't know C, or do we? We're going to need to find it. Now, you might be thinking, well, how? Because it doesn't sound like we have been told, but we have. It's not always amazingly obvious. So it's all about at time equals 0 again. So at time equals 0, the train is passing the crossing. So its distance from the crossing is 0. So at t equals 0, distance equals 0. So substitute those into our distance equation, and it might not surprise you with all these zeros that C is going to be 0, because all of that is going to make 0. Check on a calculator if you want to. It's 0. So that means our distance equation is 5t squared minus 0.25 over 3t cubed plus 26t. We're nearly there. This is an excellence question again, that's why it requires so many steps. But again, we're using those skills where it's either differentiation or integration. In this case, 2 rounds of integrating. So we've got an equation for distance, so we can work out the distance now. Because we've been told the time. How far from the crossing will the train be after 20 seconds? So we're just going to substitute t equals 20 into that equation and work it out. So at t equals 20, so d20 equals 5 times 20 squared, take away 0.25 over 3 times 20 cubed. Oh, that was not a very good 3. Plus 26 times 20. So put all that into the calculator. And we get our answer, which is 1,853.33. So just go back and check our units. This has all been given to us in meters because it's in meters per second, so the distance will be in meters. So that's going to be 1,853.33 meters. So how far will the train be from the crossing after 20 seconds? So after 20 seconds, the train will be 1,853.33 meters from the crossing. No need to convert that into kilometers or anything like that. Just leave it as it is. And there we go. That is question 1 of the 2020 calculus exam style questions complete. And a reminder, that is an excellent. To get achieved, finding the correct velocity equation, so getting to here. So 1 round of integration, finding c. Merit, finding correct distance equation, so getting to here again, including finding c. And excellence is the full answer.